So, hi to everyone. I'm happy to be here. It's like my first time giving such like a talk, so I'm a little bit nervous. We are here to learn how to hack cars and how to perform the rollback, like this, the new agnostic replay attack that I presented the last year in a different situation that they didn't disclose. I put a little bit teaser here to know that what we are going to be able to do after the talk. As we can see, we are opening and closing the car. We are checking that the car is closed. I have like a hacker ref there with the portal pack and replying some signals. We are able to execute this kind of attacks. And now the car is open without using the key fob. We have a little time today, so I'm going to be quick here. We have a brief explanation about the knowledge that we should know or we need to know before understand the two main attacks of today. And let's go into the business. Okay, everything here is considered illegal, so be careful if you want to do your own research and you want to try this kind of attacks. I'm a software security consultant at IoActive. I'm still on the last year of software engineer. I have 23 years old, and now they pay me for hack cars, you know. It's very important to know the difference about the two radios that we have nowadays. We have the traditional ones that all the stuff that they do is exclusive controlling by the hardware, and the new ones that we have are the software-defined. The new ones, you know, the software-defined radio that have some hardware parts, but the weight of the task falls onto the software, so it's making them so much powerful in the way that the traditional ones. Probably most of you, the question that you have now, it's okay, if the ECR are more powerful, which should I buy? But it's not that way, because we have a bunch of different ECR in the market, and the price ranges are like so extensive. And the question that you need to think about is, okay, what I want to do. So which kind of research I want to do, which kind of signal I need to receive. And we have like the one like only receive signals. So it's the cheapest one. You have like for $30 you can buy one. This one is have the capability to send and receive signals. I hope everyone here know like about hacker ref, JavaScript one, and if you want to do like Bluetooth things, you have the Bluetooth. And then we have these ones that are more expensive, but for this kind of engagements, we don't need. In IoActive, we have some USRP and are very expensive, but it works in really good in another engagements. But for today, with the hacker ref and JavaScript one, we are good. Jamming is illegal. You can get in trouble very easy if do this kind of stuff, so be careful. It's really important to know what is the thing about the RKE is the remote keyless entry system that all the key fob use. So it's really important to understand how this system works to be more precise when you want to execute this kind of attacks. More key fobs work in two frequencies. Depends of where the car is built. Like European, Asian, and British works in 433, and American and Japanese car on 350. They are very powerful devices because you can unlock the doors of the car. You can turn off and turn on the vehicle and a lot of different things. And the key fob are built with different chips, and the chips are implementing some ciphers to try to be more secure the communication with the car. Modulation, like everyone, I don't know if you do something with radio, but for me it's the worst part of the research, because in the software engineering didn't do anything with radio. But this is the process of modifying the information of a signals to can transmit over a channels. In the while is when you are hearing music before all the stuff, all the signals, last data that you are receiving, he before did this kind of technique modulation. We have two ones in nowadays, like the analog one, like you can see the AM and FM that everyone knows. But we have here like the digital modulation that the key fob works. We have here 3 signals that I already grabbed. And at the end, the modulation, the signals, it's 1 and 0s. That is, the car is going to receive them and is going to perform the action that it's supposed to do. So in this sector, and like in the vehicle sector, we have 3 modulation that we usually use. We have the AS key, FS key, and PS key. So it should be noted that old variant of this modulation are also using key fobs. So we have a bunch of different signals that we can receive from the key fobs. That is really important to know when you are doing the research. And I put here like 2 different slides, picture about the modulation. We have here the AC key. You can see a high peak in the middle of the image, and a variation of F's key with a frequency deviation in the middle. Here you can see like it has like 2 peaks. In this is the example of how the signal is transmitted in the way, and it's in most of the cars in nowadays that already implemented the rolling code, but in the 80s we have so many troubles about it because they used the fixed code, and this kind of techniques was like the key fob is sending some codes, and the car is receiving these codes and is comparing with a whitelist. Imagine like a whitelist. If the code is in the whitelist, the car is going to be unlocked or locked, depends of the actions that the key fob is sending. And as you can think, it's really easy to hack this type of cars, because if you are grabbing signals and in the future you are replying them, you are going to open without any security measure on the car. And that's why we have in our days like the rolling code. We can see here how this kind of security measure works. This one. Every time we are pressing the button, like a random code is on the way, and it's like a 2-way handshake, because at the same time that the kfob is sending the code, the car internally generates the same code and compare. If the code are the same, the car is going to be open or closed. If not, this is the way that the rolling codes are generated. It's very simple, but you can understand so quick. We have a code, a normal code, and we are applying a hash, and then we are generating the code. So it's be more secure, because these codes are only for one use. At the moment that we are playing the code and the car is receiving, the code is going to be invalid, and you can replay it for the future. So replay attacks is not valid here. And I put here a brief analysis about how you need to perform these techniques, because okay, everyone here likes to take your hack ref, sending some signals, and open the car without the key fob. That's awesome, but it's really important to do this kind of analysis because it's important to know what hardware the key fob is using, which kind of modulation is using, which kind of algorithm of coding is using in the bits level. And if we don't do this kind of analysis, we don't know if doing some reversing of the signals, we can switch some bits and imagine like lock to unlock or something like that and generate signal without need to receive radios, this kind of stuff. The first thing that I did is to identify the codec that the signals, the key fob is using. The other, it's identified modulation. You can see here we have AC key modulation, and we are using universal radio hacker, so the modulation is going to be automatic. And at the end, we have a no-bit codification because on the ground level, it's represent like a 0. And when he's going to up, is like 1. So it's going to be more easy to identify which kind of like Manchester encoding, 2, 1, hoping, this kind of stuff. And I put here an image about how the rolling code works in the while. You can see we have 12 different signals, and every signal is completely different. So you can't reverse in that algorithm to generate your own rolling codes. So we don't have time today, but every information will be able on the white paper that is going to publish soon. Don't worry about it. But okay, everyone here is coming for the attacks and how we can perform this kind of attacks, and trying to get like the knowledge to do your own investigation about it. It's a really nice topic, I think. So rolljam is the first attack that Sami presented on the DEFCON 23. They built this device that nowadays I think you can build for $40, $50. So it's so cheap. And this attack was disclosed on Las Vegas, but it's more sooner that the mafias were using. And it's really simple in the case. We have 4 keys. We have the owner of the vehicle, the jamming device, the vehicle, and the hacker. In a normal way, the owner is going to try to unlock the door, but the thing doesn't know that there are hackers lurking around with a jamming device that is going to stop the signal. So the car is going to be locked while the jamming is running. And at the same time, the code is sending to the vehicle, the hacker is going to capture. So we need to be able to jam in a frequency and capture at the same time. It's the difficult part of this kind of attack. In a normal way, when we are opening the vehicle and we press the button and it didn't open, we need to press another time the button, but we have the same scenario. The jamming device is still running, so the code is not going to receive by the vehicle, and the hacker is going to capture this second code. And this is the trick. Here, at the same time that we are capturing the second unlock code, the hacker is going to stop the jamming device like the first code, so the car is going to open. And the victim, the owner of the car, thinks, okay, everything is perfect. My car is open. I go to my job and anything is going here. But at this case, as we know, we have a second code that we didn't use already. So we have a second valid code that the car is going to accept. And in the wall, if I replay that code, the car is going to open. But it has a little trick. The guy is arriving to his home and he is going to lock the car. So everything perfect. The car is locked. And this is the trick about this attack. At the time that the car is locking the door, it can be like the moment that is closing the car, it can be opened in the next way. Why? Because in the moment the opening signal is triggered, in the next time, imagine we have a unlock code about him. The jamming device, like the moment that this signal, imagine that the owner sending a unlock signal right here, you need to replay all the whole attack. This is the the trick or the disadvantage that this kind of attack has, because the timing need to be perfect to execute. But imagine that the victim, that the owner didn't use the car more, and we still have the second code that didn't use, and we unlock the car and we have a new car and go home with a Lamborghini. But a brief explanation here about the methodology I usually follow. We are jamming while listening and capture the phase signals. We are jamming while listening the second signal that we said. And at the same time that we are capturing the second signal, we are going to stop the jamming device and send the first signals to open the car. It's really important to have here like a small window to receive, like I said, because if we are jamming at the same time and the same frequency that the key fob is working, we need to be able to capture the code on a scenario that a device is generating so many sound on the signal. It's the tricky part here. And if everything is going perfect, you have a second valid code to use in the future, and you have a new car and you can go home with your new Lambo. This is the how I test this kind of attack. I use GNU radio with a jammer that is operating on 433 because my Europe car is working, key fob is working on that. I made a hopping program. So, okay, I know that it's black and we are hackers, we love black backgrounds, but as you can see here, the jamming device is working on two different frequencies to automate the process and be more easy to execute. And this is the GUI of GNU that is horrible. I hate it so much, but works perfect. And I put here a small video about what I explained before. We are executing the jammer that he's working on 4333, 95 tal. And now we are a small Python program that it's only hoping frequencies to execute more easy attack. You can see here, like every 3 seconds, the hoping program is working. And this is an easy way to perform this kind of attacks if you like GNU. So don't do it. But we are getting to the business. So how rollback works, how you can perform this kind of attacks. Like you are going to see that it's a really easy one because it's in the wild it's just a replay attack. But some chips are vulnerable to the time agnostic resynchronization. The original disclosure attack was on the Black Hack the last year with these two researchers. I put here the slides of the original disclosure and the official paper that they published. So I put here a small demo. As you can see here, we have a bunch of signals that are going to be replayed. And I don't know if it has sound. We don't have sound, but you can check like the car is closed. And at the moment that we replay some signals, the car will open. So it's in the wild it's a so basic attack, but you need to understand a little bit about radio. Rollback is completely different like rolljam. So you need to switch your mind when you are doing this kind of attacks. You don't need to jam any signal, so it's more powerful than the other one because you don't need any social engineer or something like that, like timing, perfect, etc. The owner can use the vehicle as usual because we don't need to jam. So we just need to plant like a device under the vehicle, listening signal and grabbing that kind of codes. And in while, the thing that we are going to do is we are going to use some old codes, some old used rolling codes that is supposed that not accepted by the car. But if we send 2 or 3, depends on the manufacturer of this code, the car is going to be open. So it's really powerful about that because you can open only with sending 2 or 3 codes, depends on the manufacturer. is it's really powerful because if you are doing and if you find like a sequences of 3 valid codes to resynchronize the internal clock of the vehicle, and if you are doing this on June, you can go like on December, replay the same 3 codes of the car, and the car is going to still open. So this is why it's the agnostic part of the attack, and the power of this attack rolljam. The original affected vehicles are manufacturers are Kia, Hyundai, Mazda, Nissan, and Toyota. I tested on 3 new vehicles, and for now I can put. But you can see that one of them was built on 2019 and the other one 2022, and are different manufactured than that. So modern vehicles are still vulnerable to this attack, and it's heavy because it's really powerful. How rollback work? Okay, I put here a bag of 5 old codes. So these codes already used on the past. We can replay the first 2 codes, so it's really simple. And at the time that we replay these 2 codes, are going to resynchronize the internal clock of the vehicle, and on the third signal that we have in the sequence is going to be the vehicle unlocks and the counter rolling back to this state. So it's just that. The attack is going to be only without this kind of replay techniques. So it's so basics. And this is the other scenario that they presented on the Black Hat. Instead of use sequential signals, we can use like interconnect signals. In this case, 2 and 4, the blue ones. And on the 5th here, the car is going to roll it back to the state and open. So it's just that, like a dummy person can perform. Imagine that someone is grabbing your signal, you are going to the car, oh, where is my car? Okay, someone steal it because replied 3 valid codes. This is so powerful about that. And the case, at the moment that we use the other sequences, the red one that we used before is not going to be valid. So we can only use one technique at all. But, okay, we are getting now into the business. So what is the new things that we discover in the rollback attack? So this is the 2 questions that I made in the past. Like, if we can send intercalate signals, we can perform these attacks in different days. I mean, imagine that you are grabbing in a week, you are grabbing signals of a car. So what happens if someone is doing that? And I discovered like you can perform this attack in different days and in different types of code. I mean, imagine that you grab 50 codes of a car and you replay 1, 2, and 40. The car is going to be open. So this is the powerful of these techniques, and this is the thing that we need to worry about it, because you don't need to interact with the owner. You just plant a device under the vehicle, grabbing, and then in your house, analyze the signals, go other day in 4 months, and execute. As we know that the rollback principle, that we don't need jamming. Signals don't need to be sequential. Depends on the manufacturer. Need to be a strict sequential, but that is like all that you need to try. Agnostic, because the signal persists over the time, and this is the way that we send these kind of signals. This is the first scenario that I tested. I have a bag of 20 old codes that I grabbed. This code was grabbed in 5 different days, and at the moment that I replayed the first 7 and 19, the car hacked. So imagine that a hacker that plant a device under the vehicle and just listening, and in 3 months you didn't meet, you didn't see him, anyone know, and send this kind of signals between days, and the car open. Like, it's powerful. Anything is perfect, so I put here so much I fail a lot of times trying to understand this attack, and we have the same 20 codes, but at the moment that I use 1, 7, and 14, the car say me, okay, go home. You are not going to open. But why this is happening? This is why you need to analyze the signals and the chips and this kind of stuff, because you need to understand why this in these sequences is not working. But if we replay the 19-1, yes, this is the problem. So I crop 2 signals, even signals and odd signals like 1 and 2. You can see here now that we have a peak on that signal, and in the odd one, the displacement on the peak is on the right part. So this is a little bit weird. And every even signal has on the left side, and every odd signal has on the right side. So if you go in deep and you see the bit, you are seeing, like in this case, the unlock or lock signal is sending on this peak. So that's why if we are sending like the 1, 7, and 14 signal is not going to open, because in this special case, just the rollback can be executed if with odd signals with odd signals and even signals with even signal. At the moment that you are saying sending odd with even, the car is going to say, okay, go home. I'm not going to resynchronize the internal clock. Try another time. The second scenario that I discovered here is, okay, we have 3 different signals with a time frame between them. So everything is going like the original one. Now you are thinking, okay, what's new here? This is the other case that is really powerful, because this signal was grabbing in 4 different days and in a box of 50 codes. That means that the owner used the car 15 times. As you can see, this is the first signal that you grab, then the 26, and the last is the 50. So this is one of the things that is really powerful of this attack, because you can play like a hoping codes in between signals, and you don't interact. I didn't interact with it was my friend, but imagine if a hacker or a bunch of hackers do that. It's really powerful. So in this kind of attacks, you didn't have any methodology. Just analyze the chips, try to take the manufacturers. I didn't have access to the official documentation, so I couldn't do like the version of the firmware. I couldn't disassemble the car because it was my own car and my friend's car. And the things that I did was like trying to read a lot, scripting to automate some process like the rolljam attack, and fail. You need to fail. In this kind of things, you need to fail, you need to test and do different stuff, see how the car works. Like if I send it this signal, the light is going to up, something like that. Now we have the video here, as we can see before. Now we understand why if we send in these 3 signals, the car is open. This is with a street with plus TimeFrame. And this is another vehicle tested. As you can see in the middle of the screen, we have a bunch of sound. And this is another type of attack. We are testing that the vehicle is closed. At the moment that we send a special radio, the car will open. So the new findings. Okay, more vehicles still affected. The last vehicle that I tested was built in 2022. Jamming is not necessary. And the Black has said that you need to jam, but it's not necessary like you see. this kind of attacks could be possible to execute because it's the same flow in some manufacturers. If you went to your old manuals of vehicles, some of them said, okay, to resynchronize the key fob, you need to press unlock button 5 times and then put into the door and open it. That's the way that they resynchronized in the past. That's the way modern vehicles are still vulnerable. And if you buy a new vehicle, you are not going to see in the manuals how to resynchronize the clock. It's more powerful than we thought because you can repeat with jump of 50 codes and depends of code hopping, not the days hoppings. Mitigations. You need to discard, the manufacturer need to control good like the old codes. It's really important to physical resynchronization of the key fobs. So you can't resynchronize the clock with the key fob, jamming devices measure 4S, and anti-jamming technology. Like it depends. This is a really expensive way, but if you buy a expensive car, it needs to be secure, you know. And okay, that's everything. Hope you will learn something new. Thanks for the conference to be part of me here, and that's all.